Welcome to approximating extrema and relative extrema. So for example, consider the graph of f of x below, which is defined on -5 to 7. So the first thing we want to do is approximate the absolute minimum. So if we look at our graph, we're looking for the absolute minimum. We're looking for the point furthest down, the y value furthest down. So in our graph, it appears that our absolute minimum is going to be way down here. That's the farthest down the graph goes on our interval. So in this case, if we look for the y value, it looks like it's about -4.5. I apologize, the light's doing something strange. Next up, we want to approximate the absolute maximum. So for the absolute maximum, we're looking for the highest point on the graph. Right? So again, this was the lowest point, the lowest y value. Here. The lowest y value on the graph for the absolute minimum. The absolute maximum will be the largest y value on the graph. So in this case, the highest we go is that point at the end right there. And again, if we track that point, that's at what, 2, 4, 6, 8, 10, 12, about 12.8. And then the relative minima just are locally the lowest point. So it doesn't matter what's going on elsewhere on the graph, it's just locally the lowest point. So again, we're looking for, it's the lowest y value nearby. So the point that's our absolute minimum in this case is also our lowest y value near it. And so you could say that -4.5 is also a relative minimum. And then relative maximum, we're looking for the highest y value, at least nearby it. So our point at x equals -3, at least nearby that point, that's the highest the graph goes. Now we know that if we go all the way over to our x equals 7, the graph goes much higher. But at least near x equals -3, that's our highest point. And so at that point, the y value is approximately 6.5. So these are our relative minima and relative maxima versus absolute minimum and absolute max. All right, so we're going to look at one more. So now we consider the graph of g of x defined on -5 to 5. The first thing we want to do is approximate the absolute minimum. So again, the absolute minimum, we're looking for the point, the lowest point on the graph. So if we find the lowest y value on the graph, there it is on the far left, is our lowest y value, and that is at -2, 4, 6, 8, 10, 12. And then if we instead search for the absolute maximum, we are looking for the highest point on the graph. So if we search for the absolute maximum, the highest point on the graph, well, the farthest we go up is over at x equals -1. So this is the highest point on the graph, or the highest y value on the graph. And it happened at approximately, or the y value was approximately 8. And now if we want any relative minimum, we're just looking for locally the highest point. The highest y value, at least nearby. So we have a couple places this happens. So here's the highest point nearby, and then we also have a highest point nearby at x equals 4. So we have relative minima of, the first one was approximately 8, and then the next one is approximately, sorry, not 8, 4. Both of these should be 4s, not 8s. So our relative maxima, we have a locally high 4 and a locally high -1. Sorry, I did maxima, not minima. Relative maxima. And this one will do minima. So for relative minima, we're looking for the lowest point on the graph, or locally. So the lowest y value nearby. And there's just one of these local. So notice I'm not using the endpoints for the relative. I'm just using the sort of ones in the middle of the graph. And so we have one place where we kind of reach a bottom and head back up. And that y value is what, -5. So if we look at kind of all the points we found, the absolute minimum or maximum had to either occur on an end or at one of our places we turned around. Right, so in this first graph, the max was at an end and the min was at a place we turned around. Versus in the second one, it was vice opposite. Right? So the absolute max and min occurred at either an endpoint or a relative max or min. And those occurred where the graph turned around. Right? So the relative max and min occurred where the graph turns around. Now, if we look at sort of the types of places the graph could turn around, the graph either turns around at a nice smooth hill or valley, or it turns around at a sharp point. So the graph turns around at a hill or valley. A key point here is, so if we turn around at either the hill or the valley, the place where it turns around is slope 0 or has derivative 0. So the graph turns around at a hill or valley where the derivative is 0. Or at a sharp point, which is called a cusp. And at a cusp, the derivative is undefined. So it turns out that the derivative being 0 or the derivative being undefined does not guarantee that we're at a relative max or min, but we will not have one of those without one of these two statements being true. So in our next videos, we'll deal with that scenario.